Hello everyone! In this video, visualization of the results from the Times Ames mutagenicity model predictions will be presented. The Times software is a platform for kinetic and non-kinetic models for predicting human health toxicity endpoints such as genotoxicity, in chemical reactivity, receptor-mediated effect, skin sensitization, and other. For the purpose of this demonstration, prediction results from in vitro Ames mutagenicity model accounting for S9 metabolic activation will be demonstrated. Time system allows predictions to be obtained for list of chemicals, selected chemicals, or a single chemical. In this demonstration, prediction will be provided for a single chemical. As indicated, the prediction is positive due to identification of alerts in the simulated in vitro S9 metabolites. They are also highlighted in the simulated metabolic map. Times simulates in vitro rat liver S9 metabolism using probabilistic approach, where the molecular transformations are prioritized according to their feasibility of occurrence, expressed as probabilities. Those probabilities are associated with the kinetics of the reactions. The following animation will illustrate the work of the metabolic simulator. For the current example, few molecular transformations have been selected from the transformation table. Quantitative assessment of feasibility of molecular transformations controls propagation of the simulated pathways. Let's now submit a chemical for metabolization. The first transformation is not applied because there is no match between the chemical and the transformation. The next transformation is also not applied for the same reason. The third transformation is applied. There is a match and the transformation is executed. We have the first parent-daughter relationship. Next transformation is also executed. Here we have the second parent-daughter relationship. After exhausting of all transformations, the same procedure is applied using the metabolites. Let's go back to the predicted chemical. One could see that the chemical is flagged with yellow, which indicates that it has observed Ames mutagenicity data which is provided in a separate window. One could see all experimental Ames mutagenicity data of this chemical in different salmonella strains. The green label indicates for availability of documented metabolic map, which along with collected documented pathways of other chemicals is visualized in another window. Here is documented metabolic map supported by literature sources. Visualization of the model prediction is provided in the simulated metabolic map. The metabolic map contains sequences of phase 1 and phase 2 molecular transformations. Quantity of the simulated metabolites is estimated based on probability of its obtaining and probability of its subsequent metabolization. Those two probabilities can be displayed in the metabolic map. Probability to be obtained is estimated as a product of probabilities of all transformations leading to the generation of the corresponding metabolite. On the other hand, probability to metabolize depends on probabilities of all transformations which are directly applied on the metabolite. This probability is shown in the transformation table and is estimated by optimization procedure. Distribution of the parent chemical and its metabolites based on their quantities is provided in the distribution graph. Quantity is calculated in mole per mole parent. The first bar shows quantity of the parent compound, whereas the other bars in the graph show quantities of the generated metabolites. In addition, distribution of the parent and metabolites can be provided with respect to physicochemical properties such as log QW, and water solubility. The metabolites containing the alerts for DNA binding are highlighted by default. The system provides information for the alert, causing the positive effects supported by mechanistic justification. Mechanistic justification, along with other details associated with the alert, such as structural boundaries, training set, reliability, all this will be addressed in a separate video. The simulated metabolism could be validated by comparison with the documented in vitro S9 metabolic map of this chemical. Documented metabolic map is provided in the left half of the window supported by literature sources. Simulated metabolic map is shown in the right half of the screen. Sensitivity of simulated metabolic map indicates for the proportion of simulated metabolites which are also documented. Different colors are used to indicate for consistency between simulated and documented metabolic maps. As seen, both metabolites containing the DNA binding alerts are also documented. Yellow framed metabolites, as many such cases in the models, are intermediates which are not documented. However, transition between two green metabolites should pass through generation of such intermediates. Adequacy of their generation is confirmed by experts. Orange framed metabolites are simulated products of phase 2 metabolic reactions which are often omitted from the documented metabolic maps. Thank you so much for watching this video. If you're interested in times, please contact us in the links provided below.